Imagine trusting your life to a tiny piece of steel. Every car, airplane, and machine depends on springs working perfectly every time. Most people never think about this, but one broken spring can shut down an entire factory or send a vehicle dangerously out of control. Yet every perfect spring begins its journey as ordinary steel, transformed through astonishing heat, pressure, precision, and decades of engineering knowledge. Today, we're stepping inside the hidden world where red-hot metal twists into components trusted by billions of machines across our planet. But here's what nobody tells you. Some springs survive millions of compressions without losing even a fraction of their original strength. How can a simple coil survive punishment that would destroy almost any other piece of metal? That's our journey today. Everything starts with iron ore mined deep beneath Australia, Brazil, Canada, and Sweden, where gigantic machines uncover Earth's hidden metallic treasure. Some mining trucks carry over 400 metric tons in one trip, enough raw material for thousands of precision steel springs. The ore travels hundreds or even thousands of kilometers by rail and cargo ships before reaching powerful steel-making facilities around the world. Inside blast furnaces reaching nearly 1,500 degrees Celsius, iron separates from oxygen and becomes molten metal. At roughly 1,538 degrees Celsius, iron melts completely, creating a fiery liquid brighter than the afternoon sun. Engineers carefully add carbon, chromium, silicon, manganese, and vanadium, transforming ordinary iron into spring steel built for extraordinary endurance. Most spring steels contain about 0.6 to 1% carbon, balancing incredible flexibility with remarkable strength under constant stress. Even tiny chemical variations can weaken a spring dramatically, which is why laboratories verify composition with astonishing microscopic precision before production begins. But the steel still isn't ready. One invisible transformation must happen next, and it changes everything about the spring's future performance. Those glowing steel billets now enter powerful rolling mills, where enormous forces reshape them into long, perfectly uniform steel wire. Each rolling stand squeezes a steel smaller, reducing its diameter step by step, while preserving remarkable strength throughout the entire length. Next comes wire drawing, where hardened carbide dies pull steel through openings barely wider than the finished wire itself. Some production lines pull wire faster than 20 meters every second, creating kilometers of flawless spring material every hour. What happens next surprised even experienced engineers, because this perfectly straight wire must now become an incredibly precise spiral. Computer-controlled coiling machines wrap steel around hardened mandrels, forming each spring with astonishing speed and microscopic precision. Many machines produce more than 100 springs every minute while maintaining tolerances measured in tiny fractions of a millimeter. Every twist stores invisible energy inside the metal, giving springs their incredible ability to compress and instantly recover their original shape. But coiling alone isn't enough. Hidden stresses remain trapped inside every fresh spring, waiting to cause future failure if ignored. That's why thousands of springs enter heat treatment furnaces reaching about 450 degrees Celsius, or 842 degrees Fahrenheit. Inside for 30 to 60 minutes, the steel relaxes internally without losing the powerful strength carefully engineered into every coil. As the springs cool, their crystal structure stabilizes, dramatically improving fatigue resistance through millions of future compression and extension cycles. Then powerful grinders trim both ends perfectly flat, allowing each compression spring to stand straight and distribute force evenly. Every tiny spark removes microscopic imperfections, because even the smallest flaw can shorten a spring's working life dramatically. And this is where it gets truly extraordinary, because the strongest springs still haven't received their most important performance upgrade. Inside the shot peening chamber, millions of tiny steel balls bombard every spring, creating one of manufacturing's most brilliant hidden secrets. Those impacts create beneficial compressor stress, making fatigue cracks dramatically harder to form during millions of future operating cycles. Proper shot peening can increase fatigue life by more than 50% without changing the spring size or shape. Next, protective coatings shield the steel from moisture, chemicals, road salt, and corrosion that silently destroy unprotected metal over time. Some springs receive zinc plating only microns thick, yet that invisible barrier can protect steel for many years outdoors. Now every spring enters a factory's toughest challenge, proving it deserves to carry enormous forces without ever letting anyone down. Laser scanners measure every critical dimension with precision reaching just a few microns, invisible to the human eye. Artificial intelligence instantly compares every measurement against digital engineering models, rejecting even the smallest unacceptable deviation. Typical manufacturing tolerances stay within plus or minus 0.05 millimeters, thinner than a single strand of hair. Compression testers repeatedly squeeze springs under controlled loads, recording every movement with remarkable scientific accuracy and consistency. Some endurance tests continue for several days, pushing springs through millions of compression cycles before engineers approve their final performance. Even in highly automated factories, experienced technicians still detect subtle problems long before sophisticated computers recognize them. That human intuition, built through decades of experience, still protects countless products from leaving the factory with hidden defects. But here's another mystery. Where do all these perfectly engineered springs eventually end up? The answer is almost everywhere on Earth. Think about this. Nearly every moving machine on Earth depends on springs, making them one of manufacturing's most essential hidden components. Global manufacturers produce billions of springs every year, supplying industries that simply could not function without reliable elastic components. Industry analysts estimate the global spring manufacturing market generates well over $60 billion in annual economic activity. China leads global production, followed by Japan, Germany, the United States, and South Korea, each specializing in different spring technologies. Together, these countries supply automotive, aerospace, railway, medical, defense, electronics, and renewable energy industries across nearly every continent. Millions of skilled workers worldwide design, manufacture, inspect, package, transport, and install springs every single day. Did you know? The first metal springs appeared centuries ago, but industrial mass production accelerated dramatically during the 19th century Industrial Revolution. Over the last 50 years, computerized machines have improved precision from visible millimeters to nearly microscopic manufacturing tolerances. Did you know? A modern passenger car can contain well over 100 different springs working together every single journey. Did you know? Even space technology depends on precision springs inside satellites, spacecraft mechanisms, and advanced scientific instruments orbiting Earth. Engineers now develop smart materials, advanced alloys, and AI-driven manufacturing systems that could completely redefine spring production during the next decade. And this is where the journey comes full circle. A simple coil of steel quietly supports modern civilization every single day. Without these carefully engineered components, vehicles couldn't absorb bumps, machines couldn't operate smoothly, and countless everyday products would simply fail. Behind every finished spring stand miners, metallurgists, engineers, machinists, inspectors, and innovators working together across continents. Every polished coil carries millions of years of geology and centuries of engineering, compressed into a remarkably reliable mechanical masterpiece. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory. Until then, keep looking closer, because the world's greatest engineering stories hide in the smallest details.